Welcome back. The thin film transistor liquid crystal display screen is a member of the LCD family of displays. TFT screens contain numerous pixels, which are tiny screen elements that can be turned on and off in order to create visible markings. And these are organized in rows and columns. A TFT computer screen can contain many millions of these pixels. In small consumer electronics like feature phones, there are several tens or hundreds of thousands of pixels. If you use a magnifying glass on your computer screen, you will see these tiny pixels. In this color example, each pixel is actually 3, one for green, one for blue, and one for red. The circuitry that controls the screen decides which ones to turn on, how bright they should be, and how long they should stay on. The end result is rich, colorful graphics. You can see that TFT LCD screens are far more versatile than LCD character screens because there is no restriction on the things you can display on them. While on a humble LCD screen you can only display text, in a TFT screen you can draw anything at all. In this example, I'm displaying a clock on my Arduino's TFT display shield. I'll show you how to do this later on in this lecture as one of the several examples we are going to see. Because TFT screens have so many pixel elements to control, they come equipped with a screen controller integrated circuit as part of the package. Your Arduino communicates with this IC via a serial connection and makes requests for shapes to be drawn on the screen. Because the intricacies of communicating with a screen controller can be complicated for anyone other than the designers of the screen, people have created libraries like the ones we saw in the servo motor lecture and the LCD character lecture. Through such libraries, the programmer can use simple instructions like set circle to draw a circle and set str to draw a string of text. In this lecture, I'm going to use the first shield we play with in this course. A shield is a PCB on which several components are mounted, with pin connectors that match exactly those of the Arduino's headers. You plug the shield on top of the Arduino and you're good to go. No wiring and no soldering is required. This greatly minimizes chances of making a mistake and breaking something, and is a good way to experiment with more complicated devices like Ethernet adapters, SD card readers that we're going to look at in future lectures, etc. I'm now going to show you how to connect a TFT LCD screen to your Arduino using this TFT screen shield. It's the first shield I'm covering in this course. So this is what shields look like. Essentially, they are a printed circuit board that matches the layout of the pins on the Arduino, in this case the Arduino Uno. You can plug it on top of it. There's no wiring that you need to do. There's no breadboards. It's just very simple plug and almost play. Now this particular shield comes from, contains an old Nokia phone screen on it. And they come in a variety of configurations. Some of them even have a touchscreen layer on top of the LCD screen, so you can provide input just by touching on the screen. Then this one has got a joystick. So this joystick can provide some input, 4 directions plus. You can press and you can have another button. So another thing to notice is the controller. Behind the screen there's an integrated circuit that comes from 2 different manufacturers. It's going to be either an Epson controller or a Philips controller, and now I'm looking at the web page that contains documentation for this particular TFT screens, and there's many others in the market as well, but most of them are either using an Epson controller or a Philips controller, and that's important because this is something that you have to configure in your sketch before you get it to work. I'll show you that in a minute. There's a lot more information about this particular device. In terms of resolution, it's a square 128 by 128 pixels. It has 12-bit color. And it's got quite substantial functionality. In order to access this functionality, you will need to download and install the library. So this is where the library is. Download it just like we saw in the previous lecture with the servo motors. Let's see, where did it go? Okay, downloads. So here's the library. You need to copy that in the appropriate libraries directory, which is what I've done here. Again, just like we saw in lecture, I believe it was 23. So once you do that, then it will become available, including any examples will be available. So I will plug it in and then have a look at maybe a couple of examples before I show you my own scripts and explain how they work. Right, so maybe start one of the built-in examples. So the example would come with the shield, the chronometer. It's uploading. So what this does is to draw a clock on the screen. Of course, the time is incorrect because the Arduino cannot remember what time it is when it starts or when it loses power. So you're going to have to set it, and this little program comes with the ability to, say, reset the clock, or you can set the indicators to the appropriate time. It's a pretty nice effect. So you can draw graphics on this shield. But I'm not going to worry about that at the moment. I'm going to upload my first demo sketch, show you what it does, and then explain how it works. Okay, starting, and there you go. It just prints out 3 lines of text in green color and black background. Let's have a look at how it works. First of all, you need to include the library, the color LCD shield library. Don't worry about those little things at the moment. I'm going to come back to that in a minute. We declare the LCD object. Then we create an array that contains the analog pins. We're going to use analog input pins that are attached to the joystick. So although the joystick gives the ability to access 5 buttons, in this example we are only going to look at 3. In the setup function, we use a for loop to set the 3 pins as inputs. So these are going to be inputs, and then we also set the digital write for those pins to high. Right. By doing that, as you can see, the comment says that we set the pull-up resistor, which is a function in the Arduino, sets the pull-up resistors to high, enables the pull-up resistors. Then we continue with the setup. We're going to have the pin 10 being an output, so that is a serial pin, provides information for the screen to display. And we also set the backlit. So the LCD screen contains a backlit. We set it to 1023. So in this line here, we set pin 10, which is PWM capable, to be output, and we can use that to control the brightness of the backlight of the display. So you can imagine a situation where, for example, when it's dark, we can use a photoresistor to detect the brightness of the room. In that case, it's going to be dark, and we can lower the intensity of the backlight so that it's not too bright in the room. So that's the kind of functionality we achieve with these two lines. Next, we are going to initialize the LCD screen by telling it what screen it is. In my case, I'm using a Philips. In your case, it could be Epson. And we set the contrast to 40. You can play around with this value and see which value fits best with the result you're trying to achieve. Clean up the screen and then write out the first message. So we're just going to write the word starting at position 50.0. So there's going to be pixel 50 down, so the y-axis, and position 0 on the x-axis, so the very beginning of the x-axis. Then we're providing the colors. This is going to be the character color, C color, and if you scroll up here, we'll see that we have defined the constant C color to be red. Therefore, this text is going to be a red. And the background, which is another constant, set to black. Okay, I'm going to wait for a second for all this to settle, and then we're going to clear again by using the background color black to clear the screen. So the screen is going to turn to black. In the loop function, we create an array of characters, contains three pieces of string that we want to print out. We'll go through a loop and go through each one of these three strings and print them out using the print string method, which is a method or a function that we have defined at the end of this sketch. So this function accepts character pointer, which points to the thing that we want to print out, and the position, x and y integers. And we'll use the set string function of the LCD object to print out the text at the appropriate position with the character color, in this case M color, which is green. Okay, the M color constant is green, and the background color, which is black. So it is a bit involved, but once you sort out these two or three things, how you set colors, how you print out the text, how you handle positioning, it gets to be very easy. So in the first demo, we saw how we can draw text on the screen, but we didn't make use of the joystick that comes with the shield. In this second demo, I'll show you how to use the 5 buttons that are integrated into this joystick. I'm going to show you another little script where we can also take readings from the joystick and print out those readings onto the screen. So let's have a look at how it works first. Starting and then waiting for input. So I'm going to push the joystick down, so that is input number 1, to the left, input number 2, to the right, input 0, top, input 4, and pressing, that's input 3. So that's the 4 plus 1 inputs that the joystick provides. So how do we do this? Well, first we define which pins we're going to use for inputs. So these are, the joystick is connected through the shield to analog pins 0, 1, 2, 3, and 4. And then just like we did before, we set those pins as inputs and we enable the pull-up resistor. The rest of the setup function is the same as with the previous example. So let's move on to the loop. So in the loop, we just take an input constantly, which we do by calling this take input function. So we go through all of the analog pins 0, 1, 2, 3, 4 and ask to see if they've got something to tell us, if they have something written on them. So if they do, then we're going to clear the screen by writing black to all of the pixels in the screen, and then write out the message. We're going to use the print string function. We're going to pass the string that we want to write and then the position. So this is going to be Y 100 and X 0, which is towards the bottom left side of the screen. This is the print string function that we saw in the previous example. And the same thing for all of the pins. So there you have it. You now know how to use a TFT LCD screen shield with the Arduino. There's more to learn though, so let's try out an exercise. Have a look at the examples that come with the color LCD shield library. Can you figure out how to draw a line, a rectangle and a circle?